Hello everyone, how are you all? I hope you all are doing well, right? So today we will discuss our first topic, which is units and measurement. And it will be helpful for the student, those who are preparing for IIT JEE and NEET as well. Okay? And first of all, I'm starting a new series in which I will cover all the topics of physics from grade 11 and 12th. Okay, everyone? So first of all, we will discuss here about a physical quantity. So you can see here, and please everyone take the notes. It will be very helpful for you. So you can see the quantities which can be measured by any instrument and by means of which we can describe the laws of physics and that are called our physical quantities. Okay. So I have one question. Can we measure mass? So you will say yes, we can measure mass. Can we measure time? So you will say yes, we can. Can we measure temperature? So we have our different devices to measure mass, time, temperature, like we have our watch, thermometer, or our weight balance to measure all of these things. Okay, so we can say that all of these three things are our physical quantities. But can we measure our feelings? No, right? Can we measure our anger? Can we measure our anger? So you say no. So these feelings, anger, this will not come under a physical quantities. Okay. Now, measurement of any physical quantity that involve comparison with a certain basic arbitrarily chosen internationally accepted reference standard unit, which is known as unit actually. Let's suppose we have a cloth and I want to measure the length of the cloth. So how can we do that? So we'll take one scale. Okay, this is a scale and the length of the scale is 1 meter. Correct? And now from this scale we will measure the length of the cloth. So what we are actually doing, we are comparing the length of the cloth with respect to our 1 meter scale, and then we will say okay, so our cloth length is 2 times of the length of the scale. That means the length of the cloth is 2 meter. Okay, so what we are doing, we are comparing the length of the cloth from this 1 meter scale, and the length of 1 meter scale is internationally accepted. Okay, so I hope you all have got it, and if you have some doubt you can post your doubt in our comment section. Okay, I will try to reply all your doubts from there as well. Now students, we have different types of our physical quantities. The first one is a fundamental, second is derived, and the third one is supplementary. So regarding the fundamental quantities, you can see certain physical quantity that are used to express all the physical quantities, and that is known as fundamental, or we can say absolute as well as basic. So these all are our fundamental physical quantities. Okay, and they are independent of each other. They are independent of each other. So that means we can't express our physical quantity, that fundamental one, in some other physical quantities. Okay, for example, mass and time both are not depending on each other. We can say that temperature and time, they are not depending on each other, they are independent of each other, and we are saying that this all comes under our fundamental physical quantities. Okay everyone, now it's a very simple thing. So you all know that all the seven types of our physical, or seven physical quantities, that you all know, seven fundamental physical quantities. And as well as if we discuss here about derived physical quantities, so as you all know, derived physical quantities that can be expressed in terms of fundamental quantities. For example, regarding velocity, so velocity is equal to displacement upon time, right? Where displacement is a length, displacement is a length upon time. So we know length and time, these two things are, or these two quantities are fundamental. So we are expressing velocity in terms of fundamental quantities, and that is why velocity comes under derived physical quantities. Similarly, we can discuss it about acceleration, force, energy, and a lot of other derived physical quantities, okay, that can be expressed in terms of fundamental one. And we will discuss here about our fundamental. So we have seven here. The first one is length, and we represent length in meter, mass in kilograms, time in second, electric current in ampere, thermodynamic temperature in Kelvin, amount of substance in mole, luminous intensity in candela. Okay, so please everyone take the notes, and you can see some physical quantities that cannot be completely specified, that cannot be completely specified, and that is known as tensors. For example, you can see moment of inertia. So we cannot specify moment of inertia completely, even if we are knowing the magnitude, unit, and direction. That is why it comes under tensors. Okay, so it's a important term, so please take the notes as well. Now we have some rules to write the units. First of all, symbol of unit of physical quantities are printed or written in Roman upright type, not in italics. So you cannot write 10 newtons where n is italic. You can write 10 newton where n is upright, which is a correct one, but this is incorrect, this is wrong. Okay, now units is never written with capital initial letter, even if it is named after a scientist. You can see, if you are writing Newton, so this n will be a small letter, it will not our capital letter. But if you are writing the symbol of Newton, if you are writing the symbol of Newton because it's a name of the scientist, then it should be a capital C. For us unit named after a scientist, the symbol is a capital letter, but for other unit, symbol is not a capital letter. Okay, so if it is named after a scientist, then symbol will be capital. Okay, but for the other, it will a small letter. Now we have our supplementary physical quantities. You can see we have our two supplementary quantities, that are a plane angle and a solid angle. So everyone please take down the formula for finding the theta. Theta is equal to arc upon radius, you can see. And if you are saying that the angle is 1 radian, so what is 1 radian? See, if the radius of the circle, which is 1 unit, and the arc length is also 1 unit, that means arc length which is equal to radius, then we can say the angle made at the center, that will be our 1 radian angle. Okay everyone, and there is a relation between radians and degree. So radians is equal to degree into pi by 180. I think you have used this formula in mathematics. Okay, so it will be beneficial for everyone in maths as well. Now you can see the second picture, in which I have represented the different angles in degree as well as in radians. You can see 0 degree or 360, which is also 2 pi in radians. Okay, and rest of the other like 30 degrees, 60, 90, 120, 150. The value of radians is written over here, so you can all take the notes. Okay, it's a very important picture, if we can say. Now we will discuss here about our second supplementary quantity, which is a solid angle. Now first of all, you can see we have our sphere here, a sphere, and please concentrate everyone. If the radius of the sphere is r, okay, and the area on the surface of the sphere, if that is equal to r square, if area A is equal to r square, then you can see 1 astradian is the solid angle subtended at the center of a sphere. By that, surface of the sphere which is equal in the area to the square of the radius. Then we can say that angle made at the center, which is 1 asteradian. Okay, and see the supplementary quantities like solid angle, or we have a plane angle, that have only units but no dimensions, because it's a ratio. That is why. Now everyone, we will discuss more about our solid angle, or we can say asteroidian. So please concentrate here once again. As you all know, that surface area of a sphere, which is 4 pi r square. That means 4 pi value is 3.14 into r square is equal to 12.56 r square. So 1 asteroidian is equal to area, and area is equal to 1 r square, right? Now, so from this formula we can find out our solid angle, that is equal to surface area upon radius to the power 2, and we represent that our solid angle from here. Okay, so it is equal to a upon r square asteroidian, and now this a is equal to 2 pi rh upon r square, and from this square we will cancel this r, it will become 2 pi h upon r. Now what is this h here? So this h is known as height of the cap. So you can see this is our angle asteroidian, and we are just extending this picture here. Now if this is our radius r, this is also r, so this should be also r, right? And if you are saying this height of the cap is h, so the remaining distance will be r minus h. And if this angle is theta, and if I want to find out the angle theta here, so we will take the triangle, let's say ABC. Okay, if this is theta, then BC will be our perpendicular distance and AB will be our base. So we will find cos theta is equal to b by h, right? So cos r minus h divided by r, and that will be equal to 1 minus h by r. And you can see h by r, that is equal to 1 by 2 pi. So on the place of h by r, we can put 1 by 2 pi, and that is equal to 32.77 degrees. Okay, so it's a extra information that I have given you here, and it will be helpful for you in the upcoming chapters. Okay, now non-SI unit of solid angle is a square degree, or we can write it down or degree square or degree square, like that. So we can represent this non-SI unit of our solid angle. Okay, and you can see 1 degree square is equal to pi by 180 to the power 2 asteroidian, and that is equal to 3.0462 into 10 to the power minus 4 asteroidian. Okay everyone, now we have two other units, which is a practical unit and improper unit. Practical and improper. See, so first of all, if I want to ask you one question, like what is the distance between earth and sun? So we have a very large value, right? So due to the fixed size of SI units, some practical units are also defined for both fundamental and for derived quantities, like light year. So we are practically using these units. We are practically using these units like light year, horsepower, okay, mile. So this all comes under practical units. They have the large practical implications. And improper units, you can see we have one example, kilogram weight. So kilogram weight is an improper unit of weight. Why? Because we use kilogram for mass, but it is used to measure the weight, and that is why it is improper unit. Okay everyone, so it's a very simple thing, and if you have some doubt, still I repeat once again that you can post it out in the comment section. Now we will discuss here regarding a system of units. So first of all, we have our FPS, which is also known as British Engineering System. So in FPS, we represent length in foot, then our weight in pound, and time in second. In CGS, or we can say Gaussian system, so centimeter, gram and second for length, mass and time. In MKS, it is meter, kilogram and second. And we have the fourth one, which is an international system of unit, that is the modification of MKS, which is the modification of MKS system, and which is also known as rationalized MKS system. You can see. So beside the three base units of MKS system, four fundamental and two supplementary units also included in this international system of units. Okay, everyone. Now, so units of some physical quantities in different system, right? So first of all, we are measuring length in centimeter, then mass in gram and time in second, which is in CGS. And in MKS, meter, kilogram second, FPS, foot pound second. So which is the fundamental one? Regarding the derived, so we represent force in dyne, work or energy in erg, or power in erg per second. Okay, so these two terms are also important. Okay, so please remember that. In MKS, we measure force in Newton, work in joule and power in watt. But in FPS, we represent force in pound, work in foot pound and power in foot pound per second. Okay, everyone? So it's a very basic and simple thing. Now regarding the magnitude, it's a numerical value and is always constant. For example, if you're writing 10 Newton, so this 10 is our magnitude and n is our unit. Okay. And if you want to convert, for example, 1 kilogram into gram, so you know that that is equal to 1000 of grams. So to convert this, we can use the formula N1U1 is equal to N2U2. And don't worry, we will discuss about that in a briefer way in the upcoming session as well. Okay. Now you can see the fourth point, example 1 meter is equal to 100 centimeter. That's the same thing. Now everyone, you can see we have our different derived physical quantities. For example, force. So force is equal to mass into acceleration. So for mass, we represent mass in kilogram, and for acceleration, which is meter per second square. So we can say kilogram meter per second square, that is equal to our Newton. Similarly, density is equal to mass upon volume. For mass, we use kilogram, and for volume, we use meter cube. And in CGS, we can write it down gram per centimeter cube. Regarding pressure, you can see that is equal to thrust upon area. So for thrust, it is Newton, and for area, it is meter square. So Newton per meter square is known as Pascal. Okay, so we have our different units here. Now, and how we can derive that units. Everyone, regarding the dimensions, so it's a very important topic. Okay, so dimensions of a physical quantity are the powers. They are the powers, or we can say the exponent to which base quantities are raised to express that quantity. I think you all have some idea about the dimensions, like we are representing that in the terms of m to the power something, or l to the power something, and then t to the power something. So what is that? These are the dimensional formula. So it is the, or we can say, dimensional formula of any physical quantity is that expression which represent how and which of the base quantities are included. You can see the base quantities, I mean the fundamental one, the fundamental quantities are included in that quantity. For example, if I'm saying about discussing about the velocity, so I want to find out in velocity how many base quantities are included in velocity. Okay, and it is written by enclosing the symbol for base quantities with appropriate power in a square bracket. So that is important. You can see this is our a square bracket. So dimensional formula of mass, we represent mass in m to the power 1, L0 and T0, and with a square bracket. Okay. Now, so we have some dimensions here, like dimension of mass m1, L0 and T0. For length m0, L1, T0, and so on. See, regarding luminous intensity and mole, you can also write it down like m0, L0, T0, K0, CD to the power 1, and so on. Okay. Now sine theta, cos theta, tan theta, and other angles, so they are the dimensionless quantities. They don't have any dimensions. Okay, so dimensionless quantities are those to which no physical dimensions is assigned and may have a unit. They may have a unit, but no physical dimensions is assigned to them. Okay everyone, and that all comes under dimensionless quantities. So we have our dimensions for these different formulas like velocity, momentum, force, work done, temperature gradient, area gradient, velocity gradient, acceleration, then work, pressure, torque, moment of inertia, then angular displacement, angular velocity, and stress. You can see velocity is equal to displacement upon time. So for displacement we use L because it's length, and time for t. So L t to the power minus 1. For momentum, we have mass into velocity. So for mass, it is kilogram, and for velocity, meter per second. So we can use m1, l1, and t to the power minus 1. Then force, change in momentum divided by time. So mlt to the power minus 1 divided by t. So it will becomes mlt minus 2. Work done is equal to force into displacement. So mlt minus 2 into L, then it will becomes ml2 t minus 2, and so on. So if you have some doubt like how we can find out the dimensions, you can discuss with me in the comment section, and I think the derivation is sufficient enough to get that knowledge. Okay, so bye everyone, take care. We can meet again with our next topic, which is the units and dimensions part 2. Okay everyone, so please do subscribe my channel for more contents. Bye everyone, take care.